Let's move on to the next one. Question number 9. How many questions do we have in this paper? 11. Okay, so we have 3 questions left. Question number 9. Now it says functions f and g are defined for all real values of x by f of x equals 3x minus 2 whole squared plus k and g of x equals 5x minus 1, where k is a constant. Given that the range of the function gf is greater than or equal to 39, gf of x is greater than or equal to 39, find the value of k. Okay, now how do we think about this? Gf function. First of all, let's find out what the gf function is. Gf of x. What would it look like? G of f of x. That means inside g, we've got to input f. So it becomes g of 3x minus 2 whole squared plus k. Okay. And now that gives us, so inside this function, wherever you've got x, you've got to replace that with this whole thing. What do we get from this? 5 into 3x minus 2 whole squared plus k minus 1. This is what we get. This is the function gf of x. Okay. Now let's simplify this a bit. Let's multiply 5 inside, and that will give you 5 into 3x minus 2 whole squared plus 5 times k minus 1. This is what we end up getting. And now you see, what are they saying? They're saying the range of this function is greater than or equal to 39. That means the y values of this function, they have to be 39 or above, greater than or equal to 39. Now it's a quadratic function. How do you find range of quadratic functions? You have to think of the sketch of the graph, right? And see how that looks like. And look at the domain of the function. What's the domain of the function? Domain of f and g, both of them are all real values of x. So that means the composite function, the domain of that composite function is also all real values of x. So what's the range? It's a quadratic function. Is it going to be a U-shaped curve or an N-shaped curve? It's a U-shaped curve because the coefficient of x squared is going to be positive. It's going to be a curve that looks like this. Okay. They are saying the range of the function is greater than or equal to 39. That means the lowest point of this graph, that is supposed to be 39, because that is when the range of the function would be greater than or equal to 39. Right? Range represents the y values. And that means the y coordinate of the turning point, therefore, has to be 39. The y coordinate of the turning point has to be 39, because that is when the range of the function would become greater than or equal to 39. Right? If the lowest point is 39, that's when the range would be 39 or above. How can you find the turning point from this function? This part outside, it's the completed square form, although it's not the standard form because we've got the coefficient of x here inside as 3. But outside, we've got 5k minus 1. This is going to be the y coordinate of the turning point, and that is 5k minus 1. This is the y coordinate of the turning point. What about the x coordinate? For the x coordinate, you would have to put this thing equal to 0. You don't need that here, but in case we need that later, maybe let's just write that down if we need it later. What's the x coordinate? We would put this equal to 0. 3x minus 2 equal to 0. X equals 2 over 3. So the coordinates of this turning point, they are going to be 2 over 3 and 5k minus 1. These are the coordinates of the turning point. Now we know the y coordinate is supposed to be 39, right? So all we have to do is equate these two things. We say 5k minus 1 has to be equal to 39, because this is basically the turning point of the graph. And that gives you k equal to 40 over 5, which is 8. And that's the value of k that we were looking for. Okay, yes, Matul.
So why did we equate 3x minus 2 to 0?
To find the x coordinate of the turning point. We don't need that here, but in case we needed that later on, if in case we need that later on at some point, I'm just writing that down here. It's not needed here. It's not required here. It's just something extra that I'm just writing here.
So why didn't we just like equate the entire g of x greater than 39, and then we can't, and then solve it?
That could be something that you could try. You could say 3x minus 2 whole squared. No, in fact, g f of x, the function that we were getting at the end, 5 into 3x minus 2 whole squared plus 5k minus 1. Since the range is greater than or equal to 39, you could say this whole thing has to be greater than or equal to 39. But the problem is we can't really solve this inequality because we've got two unknowns. We've got x here and k here. So we can't solve this as an inequality directly because there are two unknowns. So we have to make sense of what the range of the function means in this case. The range of the function being greater than or equal to 39 means that the y coordinate of the minimum point of this function, that has to be 39. So you have to basically relate it to the turning point. Otherwise, if you try and solve this as an inequality like this, we have two unknowns. How would you solve that? That would be a problem, right?
Okay,
if it was only one unknown, we could try solving that inequality, but in this case, we can't do that. All right, that was the first part. Now let's look at the next one. It says, for this value of k, determine the range of fg. So now that we know the value of k, they're saying the value of k is supposed to be taken as 8, what you found in the previous part. Determine the range of fg. Okay, fg. Let's first of all find the function fg. What is fg going to be? F of x is equal to 3x minus 2 whole squared plus k. In place of k, we can input 8 here. That's f of x. And g of x is 5x minus 1. Both of these functions are valid for all real values of x. Okay. Now let's find the function fg first of all. Fg of x. What is that going to be? F of g of x. Inside f, you input the function g, and that gives you f of 5x minus 1. What does that give you? That gives you 3 into 5x minus 1 minus 2 whole squared plus 8. So what I'm doing is, in place of this x, I'm inputting 5x minus 1. So it becomes 3 into 5x minus 1 minus 2 whole squared plus 8. Okay. Now let's simplify this. This gives us 15x minus 3 minus 2 whole squared plus 8. And that simplifies to 15x minus 5 whole squared plus 8. We are looking for the range of this function fg. Now, again, it's a quadratic function. Fg of x, it's a quadratic function. It's a U-shaped graph, which is going to look like this. What's the turning point of this graph? Y coordinate of the turning point is 8. That's all that we're looking for. We don't really need the x coordinate. If we had to find that, that will be x equals 5 over 15, which is 1 over 3. But whatever the x coordinate is, we say the y coordinate is 8. So what about the range of the function? Remember, this function is valid for all real values of x. That means the whole part of the function is valid. What's the range? If the minimum point is at 8, you can say the range of the function is y greater than or equal to 8. That's the range of the function. You can write it like this, or you can say fg of x greater than or equal to 8. You can write it both ways. You can say y greater than or equal to 8 or fg of x greater than or equal to 8. That's the range of this function. Okay, just treat it like a normal quadratic function and then find the range of that quadratic function like you would normally do. Okay, let's move on. B square minus 4ac. Where exactly, Josefa? Okay, I'm sorry, I'm just looking at some of those start messages with A2 and A3. Which part are you talking about? Part A? Okay, here. Okay, all right. That could be another way of thinking about this. That could be another way of thinking about this. That should work as well. Although it would be easier to understand this one, I think, rather than 𝗣² minus 𝗲𝘀, but that's also something that you could try. All right. Yes. Batul, can you mute yourself again? I can't find the option to mute you from here, unfortunately. Okay, now I find it. All right, good. That was part B. Now, in the next part, it says, the function h is defined for all real values of x, and it's such that gh of x is 35x plus 19. Gh of x is 35x plus 19. This is what we're given. Okay, find an expression for g inverse and hence or otherwise find an expression for h of x. Now, how do you deal with problems like these? You've got the function g of x. What was g of x? G of x was 5x minus 1. You say let y equals g of x, and that gives you y equals 5x minus 1. You make x the subject, and that will give you y plus 1 over 5. And the function g inverse, that turns out to be x plus 1 over 5. This is g inverse. Okay. Now we are given that gh of x is 35x plus 19. All we have to do is make h of x the subject here somehow. Now for that, what we do is we introduce g inverse on the left side. We have g here, right? In order to get rid of this g from here, we apply g inverse on the left side in the beginning. So it becomes g inverse of g of h of x. Okay, but we can't just apply g inverse on the left side. We have to apply it on both sides. We say g inverse of g of h of x, that equals g inverse of 35x plus 19. So basically, since we want to make h of x the subject, what we do is, in order to get rid of this g, we apply g inverse in the beginning on the left side. And since we're doing that on the left side, it's an equation. We have to do that on the right side as well. So on the right side as well, we say, let's apply g inverse here. And now g inverse of g, they cancel each other's effect, right? They're inverse functions. And on the left side, we're just left with h of x. So we have h of x equal to g inverse of this thing. G inverse of 35x plus 19. Now you know the g of x, g inverse function. In place of x, just put 35x plus 19, and that will give you 35x plus 19 plus 1 divided by 5. So in place of x, you put this thing. Inside the g inverse function, you've got to input 35x plus 19. And now you simplify this, and that gives you 35x plus 20 over 5. And then h of x would turn out to be 35 over 5. That's 7x plus 4. That is h of x. That's what we were looking for here. That's question number 9. Is that okay? That's question number 9. Let's move on to the next one.
Sir, I didn't understand the like जब आपने composite functions को फिर h of x कैसे निकाला मुझे ये नहीं समझाया.
You understand this step?
No, I don't understand this step.
This is actually a standard process that we have in functions whenever you've got so it's very similar to what used to happen in matrices in O levels, remember? What do you find that? Composite functions, yeah. So basically, if you have something like this, f(h) of x equals g of x, and you want to find h of x, the idea is to get rid of f from here somehow. How do you get rid of f? You get rid of f by applying f inverse in the beginning on both sides. When you do that, f inverse and f, they cancel each other out, and you're just left with h of x, and h of x therefore equals f inverse of g of x. Similarly, if you had something like this, kf of x equals g of x, and you had to find k of x in this case. Now, in this case, since you have f of x here, and you want to make k the subject, you want to somehow get rid of this f. How do you get rid of f? Again, by applying f inverse. However, since f is coming on the right side here, in order to get rid of this f, we apply f inverse after f, so that when they come together, they will cancel each other's effect, and do the same thing on the right side as well. So you have g of x here on the right side, apply f inverse after g on the right side as well. Now f and f inverse on the left, they get cancelled. We're just left with k of x. K of x equals gf inverse of x. Now that's a standard process that you can use for anything like this, just like it used to happen in matrices. If you had a matrix A multiplying by B and the result was equal to C, and you had to make B the subject, what you would do would be you would multiply A inverse on the left side of the left side on both sides, right? And that will leave you with only B. So it works very similar to that. The only difference is in matrices we had to multiply matrices. In functions, we don't say we are multiplying, we are applying functions, but the concept is almost exactly the same. So that's the concept that we're actually using here. Since we had gh of x, we had to get rid of g of x somehow to get h of x, and for that we applied g inverse on both sides on the left side. Okay,
Thank you.
no problems. Okay, I think we need to be quicker from next time because this is taking a lot of time. So while explaining it, and answering questions alongside as well, it takes time. So we need to be a bit quicker about it. Maybe start a bit earlier as well. Okay, so f of x equals x plus a whole squared minus a for x less than or equal to minus a. G of x is 2x minus 1 for x being any real number where a is a positive constant. Find an expression for f inverse of x. Now it has to be in terms of a, right? Because this is f of x. When you find f inverse, you'll have this a here as it is. It will be in terms of that value of a. So let's do this. How do you start? You start by assuming f of x equal to y. Let's see what that gives us. Y equals x plus a whole squared minus a. Okay. Now, what do we get from this? We need to make x the subject now, right? So it becomes y plus a equal to x plus a whole squared. And now you take square root on both sides. But remember, whenever we take square root, we have to put plus minus, right? So it becomes plus minus square root of y plus a. And that becomes x plus a on the other side. Now take a to the other side. So it becomes x equals a plus minus square root of y plus a. So we have made x the subject here, right? That's the first thing that we had to do. We had to make x the subject. We're done with that. Now we need to decide whether to use plus here or minus here. We can only choose one of them, right? We can either choose plus or minus. Now, which one do we choose here? We need to decide that using this domain that we're given. What's the domain that we're given? I'm sorry, this is minus a here. When a goes to the other side, it has to be minus a. So let's check my working again. X plus a whole squared minus a. This had the domain given here. It becomes y plus a. And yeah, so that's what you have minus a here. Now, what's the domain that's given? The domain is x less than or equal to minus a. That's the domain that is given in the function. Now, using that domain, you need to decide whether to use plus here or minus here. The domain says x has to be less than or equal to a, less than or equal to minus a. How are you going to get values that are less than or equal to minus a? Are we going to get them using a plus sign or a minus sign? If we want something less than minus a, we'll have to subtract something from minus a to get a smaller value. So we need to have a negative sign here. So what does that become? That becomes x equals minus a minus square root of y plus a. So the sign has to be negative. Why? Because we want x to be less than or equal to minus a. If we are adding something to minus a, that will give you a value that's greater than minus a. That's not what we want. We want something less than that. So for that, we have to use minus sign. That's something that you always have to do in quadratic functions. When finding inverse, you always have to put plus minus when you take square root, but then you have to decide which one of plus or minus you are going to input there. So in this case, you have a minus here. And then you write down the inverse. You say the inverse function therefore is f inverse of x equals minus a minus square root of x plus a. That is f inverse of x. Is that okay? Any problem with this? Okay, good. Now, I'll complete this question and then I need to ask something. So we'll try to manage time better from next time. Can we continue with this at some point tonight? Will that work? So for example, what if we continue with this at 9:30 p.m.? How many of you would be okay with that? If we continue with this, after completing this question number 8, please raise your hand if you're okay with that. If we continue at 9:30 p.m. 9:30 p.m. Pakistan time, is it okay? If we complete this paper, I don't want to leave it for another day because we have a lot to cover in the next 15 days. And it's taking a bit long for now. So for next class, I'll try to start earlier and we'll try to manage it in time, hopefully. Okay, those of you who haven't raised their hands, do you have a class? So let me actually put it this way then. Anyone who has a clash with another class at 9:30, raise your hand if you have a clash with another class. Raise your hand if you have a clash with another class at 9:30 p.m. Okay, so nobody has a clash. What I'm going to do is I'm going to do it at that point. And tonight, I'll also post the recording. So in case for some reason you end up missing the class, so it will be around, I think, 30 to 30 minutes, 30, 35 minutes or something. If you end up missing that for some reason, I'll post the recording tonight as well. And from next class onward, I'll try to make it slightly more efficient, slightly more quicker. And hopefully we won't have to do it after our regular time. But for today, we're running out of time. So we will have to continue with this at 9:30 p.m. Okay, after completing this question. Now, I'll just post this on the M1 group as well, because there's time for namaz as well. So I'm just going to. We might have to do something with the timings a bit, 10-15 minutes here or there. Okay, just try to post in the other group that will be starting a bit late. But we need to do something about this, about the timing thing. Okay, so that was part A, okay? Yes, yes, we'll have a break after this. Yeah, so for Maghrib, we'll have a break, yes. So before the M1 class, yes. So we'll start at 7:10, 7:20, inshallah. I'm just going to complete this question, and then we end this class, okay? State the domain of the function f inverse. Okay, f inverse, domain of f inverse. What's the relationship between the domain of a function and the domain range of a function and the domain range of the inverse function? Domain of the original function is the range of the inverse function, and range of the original function is the domain of the inverse function. So if you want the domain of the inverse function, that's going to be the same as the range of the original function. What's the range of the original function? Let's think about that. It's a quadratic function. For quadratic functions, you always have to think using the graph of the function. What's the graph of this function going to look like? It's a U-shaped graph. The coefficient of x squared is positive, so the graph is going to be U-shaped. It's going to look like this. And it's going to be U-shaped like this. What's the turning point? Compare it with the standard form. Remember the standard form, x minus h whole square plus k. So the number that you have inside, you flip the sign for that. It becomes minus a. The x coordinate of the turning point is minus a. It's completed square form, right? And the number that you have outside, that sign remains the same. The y coordinate is minus a as well. This is the turning point. Now, which part of this function is valid? It's x less than or equal to minus a. That means to the left side of this function. This is the valid part of the function. This is the valid part of the function. Now, what's the range of the function then? Range is y values. So vertically, what's the lowest point on the graph? Lowest point on the graph is minus a. You have to be above this point. So the range of the original function is y greater than or equal to minus a. This is the range of the original function. I hope that makes sense, right? That's the standard process for finding range of quadratic functions. Look at the graph, look at what part is valid, and look at the graph. What's the lowest point? The lowest point is minus a vertically. Highest point, there's no highest point, it's going up to infinity. So the range is y greater than or equal to minus a. So now you would say, since the range of f, what's that? Range of f is y greater than or equal to minus a. What about the domain of f inverse? Domain of f inverse is going to be x greater than or equal to minus a. Remember, for domain, you always have to use x, right? So it's x greater than or equal to minus a. Is that okay? Now it says state the range of the function f inverse. What's the range of f inverse? The domain of the original function. What was the domain of f? Domain of f. What was the domain of f? It was x less than or equal to a. Minus a, sorry. What about the range of f inverse? It's also going to have less than or equal to minus a, but since we're talking about range is y values, we're going to say it's y less than or equal to minus a. This is the range of the inverse function. Make sense? So domain of the original function is the range of the inverse function. Range of the original function is the domain of the inverse function. The set of values is the same. The symbol is going to change. For domain, we use x. For range, we use y, because domain is x values, range is y values. Okay. Part C. Now it says, given that a equals 7/2, solve this equation, g f of x equals 0. Now, what were the two functions that we had? F of x equals x plus a whole squared minus a. And the domain of this function was x less than or equal to minus a. And the other function was g of x equal to 2x minus 1. And it was valid for all real numbers. Okay. Now, the equation that we need to solve is g f of x equals 0. For that, first of all, they've given us the value of a. So it becomes x plus 7 over 2 whole squared minus 7 over 2. And the domain is x less than or equal to minus 7 over 2. That's the function f of x. And g of x is this. We just have to solve this equation. Now, g f of x equal to 0. G f of x, what does that mean? That means g of f of x that equals 0. Inside g, you have to input f. So it becomes g of x plus 7 over 2 whole squared minus 7 over 2. In the g function, wherever you've got x, you're going to replace that with this whole thing. In the g function, x is going to be replaced with this whole thing. This x, you're going to input this. And then just solve that equation. Now, what do you get from this? Two into x plus 7 over 2 whole squared minus 7 over 2 minus 1 equal to 0. This is the equation that we need to solve now and find the values of x. Now, one possibility could be to expand this square and then solve it like a normal quadratic equation using quadratic formula or factorization. In this case, I think factorization is not going to be possible. Using quadratic formula, you'll have to do that. One or the other possibility, the quicker way of doing this would be to leave it like this and just simplify, or in fact, you might not even need to do that. Yeah, you can just leave it like this. So on the left side, you have x plus 7 over 2 whole squared minus 7 over 2. Take 1 to the other side. What does that become? 1 plus 1. This 2 that you have, this goes to the other side, gets divided, and you're left with 1 over 2 there. Now take this 7 over 2 to the other side. Seven over 2 plus 1 over 2, that's 8 over 2, which is 4. Now you take square root on both sides. When you take square root, remember, plus minus. So you have x plus 7 over 2 equals plus minus 2. On the left side, the square gets eliminated. On the right side, the square root of 4 is 2, and you have plus minus 2. That gives you two equations, x plus 7 over 2 equal to 2, or x plus 7 over 2 equal to minus 2. And you get x equal to 2 minus 7 over 2, which is minus 3 over 2. And x equal to minus 2 minus 7 over 2, which is minus 11 over 2. These are the two values that we're getting. But since we're getting multiple answers, we should check if both of them are possible. What was the domain? The domain was x less than or equal to minus 7 over 2. Minus 7 over 2 is minus 3.5. So the values of x, remember, it's a composite function, right? It's a composite function. Composite function is g f of x. The domain of the composite function is the domain of the inner function. So this function g f of x, this also has this domain. Inner function is f here. Domain of this function is also minus 7 over 2. X less than or equal to minus 7 over 2. So the values of x that you get, they have to be less than or equal to minus 7 over 2. Minus 3 over 2 does not satisfy that condition. So we would have to ignore this possibility. We would say this is not possible. The only possible answer is x equals minus 11 over 2. That's the only possible answer. So in the first couple of minutes, you should try and skim the paper as well, okay, to know what is coming next. So you have an idea of how much time you need to save for those bigger questions at the end. Okay, now let's have a look at this. The diagram shows the graph of y equals f of x, where the function f is defined by this. For x between 0 and 2 pi, on the diagram above, sketch the graph of y equals f inverse of x. Now, how do you draw a graph of an inverse function? You haven't really found the inverse function yet. I've asked you to draw the graph of the inverse function directly. Now, remember, a function and its inverse, they are reflections of each other in the line y equals x. So what you can do is you can draw a line y equals x and try to reflect the graph in that. Now y equals x line is going to pass through these points 0, 0, pi over 2, pi over 2, pi, pi, this and this. This is what the pi over 2 line is, y equals x line is going to look like. You would draw a dotted line like this using a ruler, okay? This is the line y equals x. You can just take 2 points like this, 0, 0, and you could take 2 pi and 2 pi and just join these 2 points using a ruler. And now you need to reflect this graph. Now it's not very straightforward how to reflect the graph. What you can do is you can take some points and try to flip them. Remember, if a function has coordinates x, y, inverse would have coordinates y, x. So the coordinates basically get interchanged, they flip. X becomes y, y becomes x. So where is this point going to go? It's slightly less than pi here. On the horizontal axis for inverse function, we're going to have this point here slightly less than pi. This is 1 point. So mark some points and then try to make that reflection. Okay, that's 1 point that we have. Now, what about this point where the graph is meeting y equals x line? When this point is reflected, the one that lies on the line y equals x, it's going to stay there. So this point is also going to lie on the f inverse function. That's another point that you have. And now that's enough to basically draw a rough shape, but let's actually represent this there as well. This is 2 pi here. So it's going to be 2 pi here. And when you reflect it, it's going to be somewhere around. So here it's slightly greater than 3 pi over 2. So its coordinates are 2 pi and something greater than 3 pi over 2. Slightly greater than 3 pi over 2. When you flip them, the y coordinate is going to be 2 pi. Right here. And the x coordinate is going to be slightly greater than 3 pi over 2. So that point is going to be around here. And now you can kind of draw a sketch like this. It would look something like this. Coming from there. This is what the graph of the inverse function looks like. Is that okay? So just try to reflect that graph. And you can try to be a bit more accurate here. For instance, do we have a point lying on exactly this point? Yeah, so for example, consider this point. That is going to be here when reflected. So the graph could be improved a little by perhaps drawing it like this instead, passing through here. Okay, this is what the graph of f inverse of x looks like, but it's a sketch. This is what it is roughly going to look like. Is that okay? You try to reflect in the line y equals f of x, y equals x, sorry. Okay, so that's the graph of f inverse of x. Okay, you should label that properly. It's f inverse of x. You should always use a pencil. You should always use a pencil for these diagrams. Okay, always use pencil for diagrams and pen for all the other working. Don't use pen for any other work. Don't use pencil for any other working. For diagrams, always use a pencil. Because then you can erase it and improve it as well. That's important. Find an expression for f inverse of x. Now, you have f of x equal to this. F of x is 3 plus 2 sine of 1 over 4 times x. And the domain is from 0 to 2 pi. How do you find inverse of this function? Well, you just follow that standard process. Let y equals f of x. And that's going to become y equals 3 plus 2 sine of 1 over 4x. And now you need to make x the subject. 3 goes to the other side and you get 2 sine of 1 over 4x equal to y minus 3. Divide 2 on the other side. And that's going to give you sine of 1 over 4x equals y minus 3 over 2. Now take sine inverse. When sine goes to the other side, it becomes sine inverse, right? So it is 1 over 4x equals sine inverse of y minus 3 divided by 2. And now 4 goes to the other side, gets multiplied, and you end up getting x equals 4 sine inverse of y minus 3 divided by 2. And I can write this in inverse form. You would say this is f inverse of x equal to 4 sine inverse of x minus 3 divided by 2. That's an expression that we've got for f inverse of x. Make sense? Any problem with this? Okay, good. Now it says the diagram shows part of the graph of the function g of x equals this. Now it's the same expression as before. Yeah. So it's the same expression as the function that we had above. However, now the domain is from minus 2 pi to 2 pi. Earlier it was only from 0 to 2 pi. Now it's from minus 2 pi to 2 pi. Complete the sketch of the graph g of x in the diagram above and hence explain whether the function g has an inverse. Now, what is this graph going to look like on the left side? How do we draw it? Now, the easiest way of doing this would be putting this function in your calculator, in the table function. I explained that in one of our earlier classes as well, but I think that was paper 3. If you don't know how to use the table function, please learn that. Just YouTube that. On your calculator, you would have a function called the table function. Okay. Use that to make a table for this. F of x equals 3 plus 2 sine of 1 over 4 times x. Put this function in your calculator in the table function. I'm going to do that on my side. Make sure your calculator is in radian mode. If you don't know how to use that, look at the P1 playlist on my channel. On that, look at the recording of P1 trigonometric graphs. And I would have explained there how to use the table function. Okay. I'm going to just use that here directly. Table. F of x equals 3 plus 2 sine of x over 2. That's what you input as f of x. Now, what's the starting value? The graph is already drawn from 0 to 2 pi. So you don't need to sketch that part. You only need to sketch the part from minus 2 pi to 0. So what you do is, in start, you're going to input minus 2 pi in your calculator, and it should end at 0. And then your step, what is the gap between these values that you have? Pi over 2. So you can have a step of pi over 2. And you get some points on your calculator. So minus 2 pi. 0, pi over 2. And you would get a table. You can just plot those values and sketch the graph like that. So at minus pi over 2, so it's starting from minus 2 pi, sorry. So it starts from here. You're going to have points here, 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 and here. Now mark the points here. The first point is 3. Why is 3 in the beginning here at minus 2 pi? Now, how do you know where 3 is going to be? Because this is in terms of pi. What you can do is you can evaluate what pi over 2 is. They're not in degrees, they're in radians. You can say, see what pi over 2 is. Pi over 2 evaluates to 1.6 something, right? 1.57. Pi over 2 is 1.57. This point is 1.57. Where is 3 going to be? 3 is going to be somewhere around, so if this is 1.57, this is actually 3.14. So slightly below that, you have 1 point here. Okay, I just need to check if this value is correct. Have I written the function correctly? Are you getting 3 for this? Have you done this in has anyone made the table in the calculator? Are you getting 3 for minus 2 pi as well? That's what I'm getting. Your calculator is going to show values in decimals. When it makes a table, X values, it converts them to decimals, and that's all right. You already know that the values are at an interval of pi over 2. So this is going to be the gap between values. You only need to look at the y values. Look at what the first y value is. So on my calculator, the first value is 3. And then the next value is 1.59. And then the next one is 1. And then I have 1.59 again. And then at 0, I'm getting 3 again. Okay, so that's what I'm getting. Let's just plot that here. At 2 pi, it's 3. And then it goes to 1.58. That's going to be somewhere around here. And then 1 is going to be 1.57, somewhere around here. And then at minus pi over 2, it's 1.58 again. And that's going to be somewhere here. And then back to this point, the graph looks like this for me. But it doesn't look correct to me because on the right side is different. So maybe I've done something wrong on my table functions. I'm just going to draw that again. It doesn't look right, to be honest. This is not correct, most likely. Let me just put this again. I think I've input the wrong function. 3 plus 2 is the function right here. 3 plus 2 into sine of x over 4. Okay, let me do this again. 3 plus 2 into sine of x over 4. Start at minus 2 pi, end at 0. Interval is of pi over 2. Yeah, I'm getting different values now. I'm sorry. These are not correct values. So they looked odd because the graph shape should remain the same, right? It's like this. On the left side, it has to be looking something like this. Okay. So I input some wrong function in my calculator earlier. Okay, let me correct this. So the updated values are 1, 1.15, 1.58, and 2.23, and 3. Okay, so it starts from 3. This is 3. And then 1.58 at minus pi. So that's going to be around here. In the middle, it's 2.23. So it's going to look something like this here. Up to this point. And then the last value, it reaches 1. V1 is going to be somewhere around here. Let me just join that like this. So making the table function, you can just make the graph like this. Okay. And of course, at the end, the graph is going to should look the same way as this because it's a sine graph, it's a cyclic graph. So whatever is the shape on the right side, it should be something similar on the left side at the bottom, in the bottom part as well. Just like a sine graph looks like this here, like this and this. So whatever the curve looks like in the upper part, it's just the opposite of that in the lower part. So the shape should look like this. And you can input values in your table function, and you will get something like this. That's what the sketch looks like. Okay, now that took time because I input the wrong function in my calculator. Now you need to explain whether G has an inverse. Does G have an inverse? When does the inverse of a function exist? When it's a one-to-one function. Is this a one-to-one function? How can you test that? Horizontal line test. Can you draw any horizontal line on this graph that cuts the graph at more than 1 point? You can't. Any horizontal line that you draw, it only cuts the graph at one single point. That means it is a one-to-one function. Since it's a one-to-one function, you would say, yes, G has an inverse because it is a one-to-one function. Okay, so it does have an inverse. Now it says describe Fourier sequence of 3 transformations which can be combined to transform the graph of y equals sine x for x between 0 and pi over 2 to the graph of y equals f of x, making clear the order in which the transformations are applied. Okay, so y equals sine x, that has to go to y equals f of x. What was f of x? f of x was this graph, 3 plus 2 sine of 1 over 4x. Okay, so that's what it should become. Now, the domain for this first graph, sine x, that's given to be from 0 to pi over 2. And for f of x, it's from 0 to pi. 0 to pi or 2 pi, it's 2 pi. What are the transformations that are taking this graph from sine x to this? Now, what transformations are happening? We have some vertical transformations, some horizontal transformations. What are the vertical transformations? Whatever happens outside the function, that's vertical. Whatever happens inside the function, that's horizontal. Now, this is the standard form, right? There are no extra brackets that they're using. So it's pretty straightforward. 6 marks, just 6 easy marks, actually, if you know your transformations well. 3 and 2, these are 2 vertical transformations. Inside, you have just 1 over 4, that is 1 horizontal transformation. So you have 3 transformations in total. Between horizontal and vertical, it does not matter which one you do first. So you could start from vertical or horizontal. It does not matter. So let's say we start from horizontal. So we start from this one, 1 over 4 times x. What's that transformation? You're dividing by 4. That's a stretch, number 1. You can say it's a horizontal stretch, or you could say it's a stretch along x-axis. Don't write stretch in x-axis. That does not mean anything. Stretch has to be written along x-axis or parallel to x-axis, or you could just write horizontal stretch. Stretch along x-axis with scale factor. What's the scale factor? We're dividing by 4. Scale factor is reciprocal of that. Reciprocal of 1 over 4, that is 4. That's the first transformation. And then you have 3 and 2 outside. These are 2 vertical transformations. In vertical transformations, in standard form, stretch and reflection are done first and translation is done at the end. So 2 is what is making the graph stretch along y-axis. That's what you do first now. Between vertical transformations, you say you first have a stretch along y-axis, or you could write vertical stretch. That's also okay. Stretch along y-axis with scale factor 2. And then the last one is a translation. You're adding 3 here. Adding 3 outside the function, that's a vertical translation. That means 3 units up. In translation, you need to write the translation vector. What's the translation vector? It's 3 units up, so that's 0, 3. Writing down the translation vector is necessary here. This is the third transformation that you have. That's it. This is what you had to do here. That's 6 marks, a lot of marks for just doing this. All right. These are 3 transformations in the correct order. This is one possible order. You could also do it this way, that you do this first, this second, and stretch along x-axis at the end. That's also fine. You could do vertical transformations first and then horizontal transformation. But between vertical stretch and vertical translation, you have to do stretch first and translation second. Otherwise, on Monday, what's the next S1 hoega? Okay. Achha. Question number 9 from this paper. Let's have a look at this. The function f is defined by f of x equals minus 3x squared plus 2 for x less than or equal to minus 1. We need to state the range of f. Okay, so it's a quadratic function. Quadratic function, or its shape kya hai? It's an inverted U, right? So it's a shape like this. जब भी आपके पास quadratic functions होते हैं, you have to be a bit careful कि आपको देखना होता है turning point पे क्या हो रहा है. अगर वो domain के अंदर आ रहे हैं, आपको उसको consider करना पड़ता है. ठीक है? अब हमें नहीं पता वो domain के अंदर आ रहा है कि नहीं आ रहा है. हम find करेंगे तो पता चलेगा वो domain में नहीं आ रहा है कि नहीं आ रहा. Now, how do you find turning point in this curve? Now, you've got multiple ways of doing this. Now, since you do not have an x term here, आप इसको इस तरह सोच सकते हैं. This is already a completed square form if you write it like this, minus 3 into x minus 0 whole squared plus 2. Right? X square को आप लिख सकते हो x minus 0 whole squared. Right? So आपका जो टर्निंग पॉइंट है उसका x कोऑर्डिनेट क्या हो गया, यहाँ पे 0 हो गया. So the turning point is therefore going to be at 0 and 2. ये इसका टर्निंग पॉइंट है. अब आपकी जो डोमेन है वो देखें कहाँ पे है, x लेस देन और इक्वल टू -1. आपने बस टर्निंग पॉइंट के देख के ये नहीं कह देना कि रेंज आपकी लेस देन और इक्वल टू 2 है. ये पॉइंट आपकी डोमेन के अंदर है ही नहीं. आपके लिए कौन सा पार्ट वैलिड है, -1 से लेफ्ट वाला. तो 0 अगर यहाँ पर आ रहा है टर्निंग पॉइंट पे, -1 इसके लेफ्ट साइड पर होगा कहीं पे. मे बी दिस पॉइंट इज -1. इसके कॉरेस्पॉन्डिंग y वैल्यू हम देखते हैं. आपका जो वैलिड पार्ट है फंक्शन का वो सिर्फ इतना वाला पार्ट है. सो अगर हॉरिजॉन्टली देखें, दिस इज 0, दिस इज -1. तो हम सिर्फ कौन सा पार्ट देख रहे हैं, हॉरिजॉन्टली -1 से लेफ्ट वाला पार्ट. अब इसमें कॉरेस्पॉन्डिंग y की वैल्यू क्या आती है वो हम फिगर आउट कर लेते हैं. फंक्शन के अंदर x की वैल्यू इनपुट कर दे -1, and that gives us -3 into -1 whole squared plus 2, and that turns out to be -3 plus 2, which is -1. इससे हमें -1 मिलता है. इसका मतलब रेंज क्या होगी फिर, ये पॉइंट आपका आ गया -1. Okay, so the range therefore is going to be y less than or equal to -1, because y axis के ऊपर you're saying इस पॉइंट से आप नीचे रह रहे हो, उसके ऊपर नहीं जा सकता. So range is y less than or equal to -1. Now you might think कि अच्छा इसमें ये टर्निंग पॉइंट निकालने की क्या जरूरत थी, आप डायरेक्टली -1 यहाँ पे डाल देते. Well, in this case आपका तुक्का लग जाता, लेकिन इन जनरल आपको टर्निंग पॉइंट हमेशा चेक करना होता है, बिकॉज अगर वो टर्निंग पॉइंट डोमेन के अंदर आ रहा होता तो आपकी रेंज चेंज हो जाती, और आपकी रेंज इंस्टेड क्या होती है उस केस के अंदर 2 से कम y लेस देन और इक्वल टू 2 आपकी रेंज आ रही होती है उस केस के अंदर. ओके, सो दैट वुड नॉट हैव वर्कड अगर टर्निंग पॉइंट आपका डोमेन के अंदर आ रहा होता. Now the second part says find an expression for f inverse of x. Let's do that. We have f of x is equal to -3x squared plus 2. Okay, क्या करेंगे सबसे पहले, we say let y equals f of x, and that gives us y equals -3x squared plus 2. अब x को सब्जेक्ट बनाना है. You can say this is 3x squared equals 2 minus y. If you bring 3x squared to the left side, y, and take y to the other side, this is what we get. Now we have x squared equals 2 minus y over 3, and then if you take square root on both sides, that gives us square root of 2 minus y over 3, but you also have to put plus minus here. Do not forget the plus minus. ओके, अब आपको चूज करना है प्लस और माइनस में से, आपको देखना है इनमें से कौन सा यूज करना है आपने. What's the domain that you're given? The domain that you're given is x less than or equal to 1. So this function is only valid when x is less than or equal to 1. अब less than or equal to -1, sorry. अब -1 से कम वैल्यू आपकी कैसे आएगी, उसके लिए ये पॉजिटिव होना पड़ेगा, ये प्लस लगाना पड़ेगा यहाँ पे, या माइनस लगाना पड़ेगा. प्लस लगाने से तो आपकी जो पॉजिटिव वैल्यू होगी वो -1 से बड़ी होगी, तो आपको यहाँ पे माइनस यूज करना पड़ेगा. So when you write down the inverse function here, you say the inverse function is f inverse of x equals minus into square root of 2 minus x over 3. That is what the inverse turns out to be in this case. Okay, minus यूज करना है यहाँ पे, इसका एक मार्क इसका होगा, साइन करेक्ट यूज करने का. Let's move on. Part C of this. It says the function g is defined by this for x less than or equal to -1. Solve this equation fg of x minus gf of x plus 8 equals 0. Okay, now let me write down f of x here as well. The function f of x was -3x squared plus 2. And the domain for that function was x less than or equal to -1. दोनों functions की same ही domain है. ठीक है. अच्छा, अभी इक्वेशन क्या है, f g of x minus g f of x. Let's write it down like this. First of all, f of g of x minus g of f of x, right, plus 8 equals 0. जो अंदर वाला फंक्शन है, जो सेकंड फंक्शन है, उसको आप एक और ब्रैकेट के अंदर लिख लें. ठीक है, Shayan, I'll come back to that question after I'm done with this part. I'll answer you in a minute. So we have f of g of x minus g of f of x plus 8 equals 0. अब हम क्या करें, f के अंदर आपने g डालना है, g वाला फंक्शन यहाँ पे इनपुट कर दें. So you have f of minus x square plus f of minus x square minus 1 minus g of f क्या है, minus 3x square plus 2 plus 8 equals 0. Remember ये multiply नहीं हो रहे हैं यहाँ पे, f इसके साथ multiply नहीं हो रहा और g इसके साथ multiply नहीं हो रहा. This is being applied on the function. f is applying on this function, g is applying on this function. f हम apply करेंगे minus x square minus 1 के ऊपर. So क्या मतलब है, ये चीज आपने input कर देनी है इसके अंदर, f के अंदर. ओके, तो इस फंक्शन के अंदर जहां भी x आ रहा है, x की जगह पे आपने ये पूरा एक्सप्रेशन उठा के डाल देना है. Let's do that. We have minus 3. You have to change this slightly so it's easier to understand. Okay, so अभी हम f of minus x square minus 1 evaluate करें. So minus 3 into minus x square minus 1 whole squared plus 2. ये आपका हो गया f of minus x square minus 1. Okay, then you have g of minus 3x square plus 2. इसमें आपको g के अंदर ये पूरा expression input करना है. So this is going to become, remember ये minus बाहर है, g के अंदर एक और minus आ रहा है यहाँ पे. So that's minus x squared. x की जगह पे आप ये डाल देंगे पूरा expression. So we have too many negative signs here. इसके अंदर दोबारा से minus आ रहे हैं. देखिए x की जगह पे आपने क्या डालना है, minus 3x square plus 2. Okay, so that's what I'm inputting here, minus 3x square plus 2 whole squared, and then you have minus 1 and the brackets closed. ये आपने evaluate कर लिया g of minus 3x square plus 2. तो function में आपने x की जगह पे ये पूरा expression डाल दिया. ठीक है, g के अंदर पूरा expression डाल दिया. Then you have plus 8 outside as it is equal to 0. Now simplify everything and see what that gives you. Minus 3 into minus x square minus 1. How do you simplify this? Is that expressions के अंदर ना, it's often simpler to take minus common. Minus अगर आप common ले लेंगे तो आपके पास अंदर क्या बचेगा, minus 1 common ले लें, minus 1 whole square तो वो खत्म हो गया. अंदर आपके पास सिर्फ क्या बचा, x square plus 1 whole square. And that will be easier in the sense कि आपकी calculation error source से कम होंगे. अच्छा, minus into minus that becomes plus. So you have plus minus 3x square plus 2. इसको expand कर लें. Minus 3x square का whole square, that's going to be 9x raised to power 4 plus 2 into minus 3x square into 2. That's going to give you minus 2 into 3, which is 6. 6 into 2 is 12. So that's 12x squared plus 2 ka square, which is plus 4. Then you also have minus 1 here. So minus into minus 1, that is going to give you plus 1. And you have plus 8 outside, that equals 0. And you have to simplify this whole expression. Minus 3 into x square plus 1 ka whole square, that's going to be x raised to power 4 plus 2x square plus 1 plus 2 plus 9x raised to power 4 minus 12x squared plus 4 plus 9 outside equals 0. Okay, now let's multiply 3 inside as well. That gives you minus 3x raised to power 4 minus 6x squared minus 3 plus, थोड़ा simplify कर लेते हैं, 2, 4 and 9. That is going to give you 15. And you have 9x raised to power 4 and minus 12x squared equals 0. अब देख लें x power 4 वाली कौन सी terms हैं, एक ये term है, एक ये term है. That they give you 6x raised to power 4. और फिर x square वाली terms देख लें कौन सी हैं, minus 6x square and minus 12x square. That gives us minus 18x square. The constants are minus 3 and 15. That gives you plus 12 equals 0. We can simplify this पूरी equation को 6 से divide कर दें. And that gives you x raised to power 4 minus 3x squared plus 2 equals 0. Now, again, it's a hidden quadratic equation. आप इसको quadratic की तरह treat कर सकते हैं. You can use a substitution if you want. If you're comfortable doing it directly, that's also fine. That's your choice. But if I use a substitution, I could say let u equals x square, and that will make it a quadratic like this: u square minus 3u plus 2 equals 0. Now, can we factorize this? It turns out we can, because it becomes minus 2u minus u plus 2 equals 0. And the factors turn out to be u minus 2 into u minus 1. So u either equals 2 or u equals 1. ठीक है, अब वापस इनपुट कर दें x square equals 2, ux square था, right? So x square either equals 2 or x square equals 1. You take square root on both sides. X equals plus minus square root of 2 or x equals plus minus 1. These are the values that we're getting from this, but you have to pause here for a moment and see, are all of these 4 answers possible? Let's go back to the question and see के वहाँ पे हमारे पास क्या conditions हैं. You can see both functions have this domain x less than or equal to minus 1. तो आपकी values क्या हो सकती है? -1 के equal हो सकती है या उससे कम हो सकती है? Positive values तो नहीं हो सकते हैं. All right, so we will consider minus square root of 2 here, yes, and minus 1 here, but not the positive values. So the answers that we get at the end are only going to be x equals minus square root of 2 and x equals minus 1. These are the only 2 answers that we have at the end: minus square root of 2 and minus 1. Okay, these are the final answers that we get from this. Now let's move on and do the next part. That was part C of this functions question. Okay, so that's it. Okay, that was question number 9. Let's move on. But before we move on, let me answer Shayan's question. So what the question was, we look at domain of original functions. Yeah. So basically, जब आप इस point पे पहुंच जाएंगे, जब आपने x को subject बना लिया होगा, इस point पे जब आपने variables interchange नहीं किए अभी, वेरिएबल्स इंटरचेंज करने से पहले अगर आप देख लें तो फिर आपको क्या करना है, बस ये जो x की वैल्यू यहाँ पे लिखी हुई है डोमेन जो ओरिजिनल फंक्शन की डोमेन, बस आपने वो चेक कर लेनी है कि वो कैसे आ सकती है. ठीक है, बिफोर इंटरचेंजिंग द वेरिएबल्स, नॉट आफ्टर दैट. बिफोर यू इंटरचेंज द वेरिएबल्स, क्योंकि अभी तक ये तो ओरिजिनल फंक्शन नहीं है. ओरिजिनल फंक्शन में हमारे पास x की कंडीशन है, x शुड बी लेस देन और इक्वल टू -1. तो अपने ओरिजिनल फंक्शन में ही ये चेक कर लेना है कि वहां पे प्लस आना चाहिए, माइनस आना चाहिए. ठीक है, एंड देन यू इंटरचेंज द वेरिएबल्स आफ्टर दैट. Okay, I hope that makes sense quickly as well. This has okay, now the votes have increased. All right, let's have a look at this. Question number 8. The function f is defined by f of x equals 2 minus 3 over 4x minus p for x greater than p over 4, where p is a constant. Find f dash of x and hence determine whether f is an increasing function, a decreasing function, or neither. Okay, so how do we think about this? Increasing function is when the derivative is positive, decreasing is when the derivative is negative. Neither means it could be increasing in some part and decreasing in some part, so we can't say it's any one of those two. So how do we think about this? We find the derivative first. F of x equals 2 minus 3 into 4x minus p whole power minus 1. So first of all, bring this to the numerator. And then the derivative of this function, that becomes 2 remains as it is, minus 3 into minus 1 into 4x minus p whole raised to power minus 2, and then multiply by the derivative of the part that's inside. That will be 4. Remember, p is a constant. So the derivative of 4x is 4, derivative of p is just 0. This is what we get. Now let's simplify this. 3 into 4, that's 12. 12, and then this is negative power. We can take that to the denominator and write it like this. We can say this is 4x minus p whole squared. That's f dash of x. Now we need to figure out, is this number positive, negative, or it could be any of the two? Can we say it's positive or negative, or can we not say that? Let's think about this. In the numerator, we've got 12. 12 is a positive number. In the denominator, we've got a square. A square can either be 0 or positive, right? So the denominator is also greater than or equal to 0. The denominator can also not be negative. Now, if it was 0, the derivative would become undefined. right? And you can see it's also not equal to 0 because the question tells you x is greater than p over 4. So the denominator would only be equal to 0 if x was equal to p over 4. And that's not something that can happen given the domain that we're given in the question. X is greater than p over 4. So x cannot be equal to p over 4. That means the denominator is also always positive because it's a square. So what do we say then? We say f dash of x is always positive or always greater than 0, right? Since it's always positive, what does that mean? Since the gradient is greater than 0, we say f of x therefore is an increasing function because the derivative is always positive. If we could not prove this, then we would say it could be positive or negative, any of them. Then we would say it's neither, but in this case, we can prove that the numerator is always positive, the denominator is always positive. So the overall result is also always positive. Make sense? That was part A. No problems in this? All right, good. Let's have a look at the next part now. Now it says, express f inverse of x in this form. So we've got the function f. F of x looks like this. 2 minus 3 over 4x minus p. And we were given that x is greater than p over 4. Okay, now we need to find the inverse of this function. How can we do that? We just apply the standard process for finding inverse. We start by this. We say let y equals f of x. What does that give us? Y equals 2 minus 3 over 4x minus p. And now we need to make x the subject. What we can do is we can first of all, let's take this term to the left side, bring y to the right. What does that give us? That gives us 3 over 4x minus p, that equals 2 minus 1. Now I could just multiply 4x minus p on the other side. Since I want to make x the subject, and I could bring 2 minus y to the left. Right? Let's see what that gives us. 3 over 2 minus y, that equals 4x minus p. And now we can take p to the other side as well. So it becomes p plus 3 over 2 minus y, that equals 4 times x. Divide the whole equation by 4. So it becomes x equals p over 4 plus 3 over 4 into 2 minus 1. Let's simplify this. X equals p over 4 plus 3 over 8 minus 4y. This is what we get. Now, what's the form that they wanted? P over a. Well, we've got that. P over some number, where a is an integer. Yes, that's correct. Then you have minus here. We've got plus here. And then in the denominator, they've got cx minus d. When we interchange the variables later, the y would become x. But here, the variable is the first term and the constant is the second term. We have the constant as the second term and variable as the second term. What we can do is, we can say, let's take minus common from the denominator. Why? Because we want minus outside here. So we can take minus common. What does that leave us with? P over 4 plus 3 over minus into 4y minus 8. If I take minus common from the denominator, now I can put this minus sign here. And it becomes x equals p over 4 minus 3 over 4y minus 8. Now I can write this in inverse form. This becomes f inverse of x equals p over 4 minus 3 over 4x minus 8. This is what the inverse function turns out to be. That's what we were looking for. Make sense? It's in that exact form that they wanted from us. All right. Now it says, hence state the value of p for which f inverse of x is identical to f of x. Where f inverse of x and f of x are exactly the same. Okay, when can they be identical? What's f inverse of x? F inverse of x is what we have found here. That's p over 4 minus 3 over 4x minus 8. That's f inverse of x. What was f of x? F of x was 2 minus 3 over 4x minus p. Right? Now you just compare the two. When will both of these be identical? You can compare. You've got p here, and that's 8. So the value of p should be 8. You can confirm from this as well. This is p over 4. P over 4 should be the same as 2. And that also gives you p equal to 8. So the value of p therefore should be 8. All right? That's what we were looking for. Is that okay? That's part C. Okay, so the first question that most of you have asked from this paper is question number 9. Let's have a look at this. It says functions f and g are defined by f of x equals x plus 1 over x. And g of x equals ax plus 1 for x such that x can be any real value. Find an expression for gf of x. Now that's straightforward. Let's find this expression, gf of x. That means inside g, you've got to input f. So it becomes g of f of x. All right. So this becomes g of x plus 1 over x. Now inside this function g, wherever you've got x, you need to replace that with x plus 1 over x. And that will become a into x plus 1 over x plus 1. And that's gf of x. That's what we were looking for. They've not really asked you to simplify this. You can leave it like this as well, and that's okay. If you want, you can write it in simplified form. You would say this is ax plus a over x plus 1. That is gf of x. Okay, that's the first part. Now it says, given that gf of 2 equals 11, find the value of a. Okay, what about this now? We've got gf of x function already. We just need to put 2 in that function and put that equal to 11, right? Gf of 2, that means inside the function gf, we input x equal to 2. What does that give us? A into 2 plus a over 2 plus 1. I've just input x equal to 2 here, and this should equal 11. Okay, that's an equation that we get. Now we can just solve this equation and see what that gives us. Multiply the whole equation by 2 to get rid of the fraction, and that will give you 4a plus a plus 2 equals 22. 5a equals 20, and the value of a turns out to be 4. That's the second part. Okay, a is equal to 4. Let's look at the next one. Now it says, given that the graph of y equals f of x has a minimum point when x equals 1, explain whether or not f has an inverse. Okay. All right, so they have given you that the function f of x has a minimum point, has a turning point when x equals 1. Now, x equals 1 is somewhere in the middle of this domain. In the middle means it's not an end point, right? If it was at 0, then that would not be a problem. But the turning point is at x equals 1. If there's a turning point at x equals 1, that's a minimum point. That means around that minimum point, if this is x equals 1, and it's a minimum, around this point, the graph is going to look like this and this, right? Around this point, x equals 1. Now, if the graph looks like this, can it have an inverse? No, because it's not 1-to-1. It fails the horizontal line test. So we can say f does not have an inverse. Why? Because it's not a 1-to-1 function. One-to-one functions cannot have turning points with inside the domain somewhere. Okay, they can't have turning points like this. Since it has a turning point, it's not, this function is not 1-to-1. All right, that's part C. Now it says it's given instead that a equals 5. That means this value of a that you found here, that's no longer relevant. They have told you that a equals 5 now. And they've given you that value in the beginning here, not inside part D. That means it's this value now is relevant for the next part. So if there's any other part as well, we've got part E as well. So this value a equals 5 is relevant for both the parts now. Now let me just write those functions here again. X plus 1 over x. That was the function f of x. And the domain for this function was x greater than 0. And the other function was g of x, which was ax plus 1. And this other function was valid for all real values of x. Now we need to find and simplify an expression for g inverse of f of x. Now, first of all, for that, we need to find the function g inverse. Let's do that first. We replace g of x with y, and that gives us ax plus 1. Make x the subject, that will be y minus 1 over a. So g inverse of x, that becomes x minus 1 over a. That's the inverse function. And now we can find g inverse of f. We can say g inverse of f of x. That basically means inside the function g inverse, you have to input f. So in place of x here, you have to input x plus 1 over x. Let's see what that gives us. In place of x here, put that thing. That's x plus 1 over x minus 1 divided by a. And that is g inverse of f of x. They also want you to simplify this. Let's simplify this. In the numerator, we can take LCM and see what that turns out to be. X squared plus 1 minus x whole divided by x over a. And now this x can go to the denominator, and it gives you x squared minus x plus 1 in the numerator. And in the denominator, you would have a times x. And that is g inverse of f of x. Right? In fact, we have this value of a given as well. Let's use that here. I'm sorry, let me just use that here, because the value of a is given. The value of a was given to be 5. So in place of a, you can put 5 here. This is 5x plus 1, y minus 1 over 5, x minus 1 over 5. In the denominator, here you have 5 and 5 and 5, and that's your final result. G inverse of f of x, this is what it turns out to be. All right. That was part D. Now it says, explain why the composite function fg cannot be formed. Okay, why the function fg cannot be formed. Remember the condition that we have for this? When can the composite function be formed? When the range of the inner function, what's the inner function in this case? Inner function in this case is g. When the range of the inner function, when that is when all of range of inner function is part of the domain of the outer function. In this case, since it's fg, the outer function is f. What's the range of the inner function? What's the range of the function g? G is a straight line and its domain is all real values. Ax plus 1 when it's 5x plus 1. Let's use this form, 5x plus 1. What is this line going to look like? It's an upward sloping line this way. If domain is all real values, range is also all real values for G, right? Because vertically, it can go up to positive infinity and negative infinity. So for the inner function, the range therefore is all real values. What about the domain of the outer function? What's the domain of the outer function? The outer function is f. Domain of the outer function is positive values. Now the problem is the function g can give you any real value as an output, and that value has to be input inside the function f. Since function f can only take positive values, we have a problem, because when function g returns a value that is negative or 0, function f would not be able to take that as an input, right? So the function will break there. So what do we say then? This function cannot be formed because range of g, all of that is not part of the domain of f. That's what we write here. You say the range of the inner function the whole range, because all of that has to be part of the domain of the outer function. The whole range of the inner function is not, you have to specify which inner function. The function inner function is g, is not part of the domain of the outer function, which is f. That is why this function cannot be formed. Okay, so you need to remember this condition for composite functions. A composite function can only be formed when the whole range of the inner function is part of the domain of the outer function. Okay, that's the condition for the composite function being formed. That's something that you need to understand well. Okay, so this function therefore cannot be formed. It looks like a good question for practice. So I'll have a look at this as well. Question number 6. It says f of x equals x squared minus 4 divided by x squared plus 4. This is the function that we've got for x greater than 2. In the first part, it says find an expression for f inverse of x. Now, how do you do that? You say let f of x equals y, and the function becomes y equals x squared minus 4 divided by x squared plus 4. All right, that's what we get. Now we need to make x the subject. How do we do that? We multiply this on the other side, and that gives us x squared y plus 4y. On the other side, we've got x squared minus 4. Now take all x terms to one side, everything else on the other side. So we get x squared y minus x squared. On the other side, we have minus 4y minus 4. Okay, and now we can take x squared common here on the left side, and that gives us y minus 1 inside. On the other side, we have 4 minus 4y minus 4, and x squared becomes minus 4y minus 4 divided by y minus 1. Okay, that's what x squared is. Now we need to decide, now we need to take square root on both sides. Now this is a negative. If you want, you could also write it as, so if you take minus common from the numerator, this could be written as 4y plus 1 inside, with the negative sign outside. In the denominator, you would have y minus 1. And then you can just multiply this minus sign in the denominator so that it becomes 4y plus 1 divided by 1 minus y. So both of these forms are going to be acceptable. You can write this as it is, and that's okay. Or you could also write, there was a 4 here. You could also write it like this, 4y plus 4 divided by 1 minus y. Both of them would be acceptable. All right. Now what we do is we take square root on both sides. How do we take square root? We have to put plus minus. When we take square root, okay, so we get minus 4y minus 4 divided by y minus 1 now inside the square root. And now whenever we take inverse and we have some quadratic term and when we take square root at the end, we get plus minus at the end. Now the problem is we need to decide which one of these plus and minus signs is going to work, is going to be applicable here. We never leave it as it is. We have to decide which one of the two is going to give us a value that is in this domain. What's the domain that's given? The domain is that x is greater than 2. Now, if x is supposed to be greater than 2, what does that mean? This number that we get, the end result from this square root, it should be a positive number. Since we want a positive number, it's greater than 2, right? We can't have a negative number that's greater than 2. Since it's greater than 2, we have to choose plus out of these two possible signs. So it becomes x equals plus square root of minus 4y minus 4y minus 4 divided by y minus 1. You have to choose the plus sign from here. Now, it's not always going to be the case that you choose plus sign. Sometimes it can be negative as well. So it's always important to think of it like this, that you first put plus minus, and then you decide based on the domain that's given, whether x needs to have a positive sign there, whether you need to have a positive sign with that square root or a negative sign. You always have to decide it like this based on the domain that's given in the question. Okay, so in this case, we choose positive sign there. And now we can say f inverse of x, to be honest, minus 4x minus 4 divided by y minus 1. And then you have square root like this. Okay, that's f inverse of x. You could also take 4 common from the numerator. And then square root of 4 is 2. You could write that 2 outside as well if you wanted. It's not necessary. You can also leave it like this, and that's also fine. That's also all right. Okay, so both ways will work here. And that's the inverse function that you get. All right, now let's move on. Let's move on to the next part. Now it says, show that 1 minus 8 over x squared plus 4 can be expressed as this, and hence state the range of f. Now, how can we do this? We've got two separate terms here. We want to convert them to a single term, a single fraction. We can take LCM. If we take LCM there, we get x squared plus 4 minus 8 divided by x squared plus 4, right? So x squared plus 4 gets multiplied by 1, and you get x squared plus 4 here, minus 8. And now you simplify this, this becomes x squared minus 4 divided by x squared plus 4. And then they say, hence state the range of f. Now, what was f? F of x was basically the same expression. It was this expression. Let me write that down. F of x was actually equal to x squared minus 4 divided by x squared plus 4. And the domain that we were given was x greater than 2. Now, they've made us show that this expression is actually the same expression as this. And that is what you would use instead to find the range of this function. Now, you've already converted it to this form. This is the form that you would use now to understand what the range of this function would look like. So you write it like this. You say this is the same thing as saying 1 minus 8 over x squared plus 4. And now this is the domain that we're given, x greater than 2. We need to find the range of this function f. Now, how do you do that? It's a reciprocal function. In order to find range of reciprocal functions, we have to think of it like this. You say, okay, x is supposed to be greater than 2. So one extreme point that you have in this domain is 2, right? That's the minimum possible value. It's not exactly 2. It's going to be something slightly greater than 2, but that's one endpoint. And the other endpoint for x is basically infinity. Right? So the least possible value of x is 2, and the maximum possible value of x is infinity. And now we need to figure out what the corresponding possible values for f of x can be. Now let's think about that. what about the corresponding f of x values? We can input x equals 2 here, and that will give us the corresponding value when x equals 2. When we input x equals 2 there, what do we get? We get 1 minus 8 divided by 2 squared plus 4. And that gives us 1 minus 8 over 8, which is 0. This turns out to be 0. That means when the value of x is equal to 2, the value of y, the value of the function, that is equal to 0. This is one endpoint that we're getting for the function f of x. And then we think about what happens if x was to become very large. If x was to go towards infinity, right? X greater than 2 means it can go as far as positive infinity on the positive side, on the right side. Now, what happens when x goes towards infinity? Let's think about that. F of x equals 1 minus 8 over... Okay, I'm sorry. Yeah, you're right. I did not change x there. Is that what you're saying? Yeah, I'm sorry. This was actually x there. Yeah, minus 4x minus 4 divided by x minus 1. This x was not replaced there. Yeah, thank you. That's correct. Okay, now what happens when x becomes extremely large? What about that? 1 minus 8 over infinity square plus 4. What's infinity square plus 4? That's still an extremely large number. So we can say 1 minus 8 over an extremely large number, infinity. What does that mean? This whole thing, because it's 8 over an extremely large number, this is going to go towards 0. And we're going to be left with 1 minus 0, which turns out to be 1. So when x goes towards infinity, the value of the function that goes towards 1. So one extreme point for f of x is 0, and the other extreme point for f of x is 1. So what do we say about the range now? We say the range of the function, f of x, that is between 0 and 1. That is the range of the function. You can say y is between 0 and 1, or you can say f of x is between 0 and 1. Both of them will be acceptable. All right. Now, you don't put equal to signs with both of them here. Why? Because you see x equals 2 was not included in the domain. So the corresponding value for f of x, which is 0, that should also not be included. So we don't put an equal to sign with 0 because of that, right? Because 2 did not have an equal to sign here. And then what about the other value, 1? Well, we're saying when denominator becomes very large, this value is actually going to be very close to 0. It's not going to be exactly 0. It's going to be something like the 0.000000, and then maybe some 1 at some point. So this is also not becoming exactly 1. It's becoming something very close to 1, right? That is why we also don't put an equal to sign with 1 here as well. With both of these numbers, we have a strict inequality from 0 to 1. And that's your final answer. Is that okay? All right. That was the second part. Now, part C, it says, explain why the composite function f cannot be formed. Now, what is f? F of x. That is basically f of x, right? This is what this function is. Now, in this case, f is an inner function, and f is also the outer function. F is both the inner function and the outer function. Now, remember the condition that we had for a composite function being formed. The condition is that the whole range of the inner function, it should be part of the domain of the outer function. Whole range of the inner function, it should be part of the domain of the outer function. Now, in this case, both the inner function and the outer function, they're both the same. Now, let's think about it. What's the inner function in this case? Inner function is f. Outer function is also f. What's the range of f? The range of f is this, what we have found here. It's from 0 to 1. Domain of f, what values can it take as an input? It can only take x greater than 2 as an input. Now you can see we've got a problem. This is what the function f is giving you as an output. A number between 0 and 1. This number cannot be input here because f can only accept values that are greater than 2. The output that's coming from f is between 0 to 1, and the input that it can accept is greater than 2. So we have a problem. The function cannot be formed. So what do we write then? We say the whole range of f is not part of the domain of f. That is what you would write there. This is what's going to earn you this mark. That the whole range of f is not the part of the domain of f. If it was some other function, fg for instance, you would say whatever is the inner function, the range of that is not part of the domain of the outer function. Okay, in this case, both inner and outer functions are the same. So this is what you can write. This is what is going to earn you this mark, this statement. Okay, and that's the logic of it that you understood there. This is what we will write there. Is that okay? Make sense? That was the functions question. Okay. So this is the next question that we found difficult from this paper, question number 10. Let's try this now. It says functions f and g are defined as follows. F of x equals 2x plus 1 divided by 2x minus 1 for x not equal to 1 over 2. And g of x equals x squared plus 4, and x here can be any real value. The diagram shows part of the graph of y equals f of x. State the domain of f inverse. What's the domain of f inverse? Domain of f inverse is going to be the same as the range of f. What's the range of f here? Can you understand the range of f from this graph? You can see this graph is going vertically upwards here, right, like this, and it's going vertically downwards here like this. So what's the highest possible point on this graph, and what's the lowest possible point on this graph? Highest is positive infinity, lowest is negative infinity. Is there any exception? This value, y can be anything except 1. You can't have a y value of 1 from this function. You can see that in the graph. Y is anything in the positive direction is going up to positive infinity. It can be anything in the downward direction is going up to negative infinity. Sorry. It's going anywhere up to positive infinity and negative infinity. However, it's not touching this y equals 1 line. So the y value cannot be equal to 1. So the range of f, therefore, the range of f is basically all real values, except there's one exception, and that is that y cannot be equal to 1. That's the range of the function f. Now, what about the corresponding domain of f inverse? It's the same as that. What would we say? Domain of f inverse is the range of f. You would just change the variable because domain means values of x. You would say the domain of f inverse, therefore, is all real values There's one exception, and that is x cannot be equal to 1. This is one possible way of writing this. You could also write it like this, that the range would be x greater than 1 or x less than 1. Because it can't be equal to 1. It could be anything greater than 1 or less than 1. You could also write it like this. Both of them are going to be acceptable. Is that okay? How do you figure that out? By looking at the graph of this function. Any problems with this? This was slightly tricky. Now it says, find an expression for f inverse of x. So now we need to find the f inverse function. How do we do that? We have f of x given. F of x equals 2x plus 1 divided by 2x minus 1. That's the f of x function. We replace f of x with y. That gives us y equals 2x plus 1 over 2x minus 1. Multiply this on the other side, and that will give you 2xy minus y equal to 2x plus 1. Take x terms to one side. You get 2xy minus 2x equals y plus 1. Take x common, that leaves you with 2y minus 2 inside. On the other side, you have y plus 1, and x equals y plus 1 divided by 2y minus 2. And then you can write down the inverse function. You can say f inverse of x, therefore, is equal to x plus 1 divided by 2x minus 2. That is the inverse function. Okay, that's pretty straightforward. You just make x the subject and then replace the variables. This is what you end up with. Now let's look at the next one. It says find GF inverse of 3. They've only given us 2 lines for this. Okay. GF inverse of 3. What does that mean? G of F inverse of 3. Inside G, you have to input F inverse of 3. Now, what is F inverse of 3? You input x equal to 3 here in place of x, right? What does that give you? You can also first evaluate f inverse of 3 if you want, and then input that inside G. That might be simpler to write. Or you can just write it like this as well. It's your choice. It's G of f inverse of 3. What's that? That's 3 plus 1 divided by 2 into 3 minus 2. Now let's simplify that. 4 divided by 6 minus 2, and that just gives me 1. So you have G of 1. This is what you need to evaluate. Inside the function G, just input x equals 1 now. This is G function. It's x squared plus 4. So you say 1 squared plus 4, and that results in 5. This is the value of GF inverse of 3. Okay, that's what we had to find here. Let's move on. Now it says explain why G inverse cannot be found. Now that's actually a standard question. You should remember the response to this. What was G of x function here? It was x squared plus 4. And it was defined for all real values of x. It's a quadratic function, which is not one-to-one. And inverse only exists for one-to-one functions. So why G inverse of x cannot be found? Because G of x is not a one-to-one function. Right? It's not a one-to-one function. Inverse only exists for one-to-one functions. Now it says, show that 1 plus 2 over 2x minus 1 can be expressed as this. Hence, find the area of the triangle enclosed by the tangent to the curve y equals f of x at the point where x equals 1 and the x and y axes. Okay, so first of all, we need to show that this thing can be expressed as this. 1 plus 2 over 2x minus 1. Let's simplify this, take LCM, and that will give you 2x minus 1 plus 2 divided by 2x minus 1. And that simplifies to 2x plus 1 divided by 2x minus 1. All right, that's what we get. So that's the first thing that we had to do. We had to prove that this thing can be written like this. Now it says, hence find the area of the triangle enclosed by the tangent to the curve. Okay. The tangent to the curve at the point where x equals 1. X equals 1 here. We've got a point on this curve that will look like this. The tangent will look like this. Triangle enclosed by the tangent to the curve and the x and y axes. So this is what the triangle becomes. We need to find the area of this triangle. How do you find the area of this triangle? It's a right angle triangle. For a right angle triangle, we can find the area if we know the base and the height. What are the base and the height here? What you can do is you can figure out the equation of the tangent. You can find the equation of this tangent and then find the x-intercept of that tangent. That will give you this point. And find the y-intercept of that tangent. That will give you this point. You'll have both the base and the height. You can use the area formula for triangle then to find your result. Okay, let's do that. How do you find the equation of the tangent? You have the curve given. F of x equals 2x plus 1 over 2x minus 1. They've already told you that this can also be written as 1 plus 2 over 2x minus 1. So you will use this form instead. Because this you do not know how to differentiate in paper 1. Those of you have done paper 3, you'll have to use you could use quotient rule here or product rule by bringing the denominator to the numerator. But if you're at AS right now, you don't know how to differentiate these functions like these, right? For that reason, they have told you that this can also be written like this. If it can be written like this, now you can just differentiate both of these terms separately. You can say this can be written as 1 plus 2 into 2x minus 1 whole raised to power minus 1. And now we can differentiate this thing. Let's find the derivative. F prime of x or f dash of x. Derivative of 1 is 0. Derivative of this expression, 2 remains as it is, multiply by the power. What is inside remains as it is. Subtract 1 from the power, it becomes minus 2. Multiply by the derivative of what is inside, you multiply by 2 here. And that should give you an expression for f dash of x. Let's see what that turns out to be. Minus 4 over 2x minus 1 whole squared. Now we need to find the equation of the tangent. At what point when x equals 1? Let's input x equals 1 here because that will give us the gradient of the curve at that point. When we input x equals 1, we get f dash of 1, and that equals minus 4 over 2 into 1 minus 1 whole raised to power 2. And that will give you some value. Minus 4 over 1, that's going to be minus 4. This is the gradient of the curve. Gradient of curve at x equals 1. If the gradient of curve is this, that's also going to be the gradient of the tangent. That will also be the same. So once you know the gradient of the tangent, now you can find the equation of the tangent using this. You already have a point, right? This point lies on the graph. Since you have the grid given as well, you can just see from the graph, this point is supposed to be 1 and 3. You can confirm this by inputting x equals to 1 in this function as well. And that will give you 3 over 1, which is 3. So the point that we're talking about is 1 and 3. This is the point. Okay, so now you've got the gradient. and you've got a point, can you write down the equation of the tangent? Y minus y1 equals m into x minus x1. It will be y minus 3 equals m into x minus 1. This is the equation of the tangent that we're talking about. Let's simplify this. It becomes minus 4x plus 4 plus 3, which is going to be 7. So we know the equation of this line now. Okay. Since we're looking for the area of this triangle, we can find the x-intercept of this line and the y-intercept of this line. How do you find both of those values? You put x equal to 0 here. That actually gives you y equals 7. You can see that on the graph. See that here as well. This is supposed to be the y-intercept. That's 7. Okay. Then you also input y equal to 0. When you input y equal to 0, that gives you x equal to 7 over 4. So now we know that this point here is 7, and this point here is 7 over 4, where the tangent is actually supposed to meet the x-axis. I just drew an estimate, right? You can only find by calculation what the actual point is. The actual point is at 7 over 4. So this is what the triangle looks like. We can find the area of this triangle now. What's the height of the triangle? 7. What's the base of the triangle? 7 over 4. You can just use half into base into height now to find the area. The area, therefore, is equal to 1 over 2 into base, which is 7 over 4, into height, which is 7, and that should give you the result 49 over 8. That's 6.125. That's the area of that triangle that we were looking for. That's our final answer. Working. अगर आपने खुद से नहीं किया तो जो क्लास नोट्स हैं उनसे वो सारे क्वेश्चंस डिटेल में देखते हैं, उससे आपके सारे कॉन्सेप्ट्स क्लियर हो जाएंगे. और फिर और प्रैक्टिस के लिए ट्राई रीसेंट पेपर्स 2020 ऑनवर्ड. जितने पेपर्स आप ज्यादा कर सकते हैं, टॉपिकल आप कोई भी दे लें और रीसेंट पेपर्स भी अटेम्प्ट किया करें साथ साथ. ठीक है, दैट्स इंपॉर्टेंट. Okay, let's have a look at this. We have this diagram that shows the graph of y equals f of x. On this diagram, they say sketch the graph of y equals f inverse of x. f inverse का ग्राफ बनाना है. इसके अंदर देखिए कुछ भी उसने पहले नहीं कराया, आपको पॉइंट्स पे नहीं पता, आपने स्केच करना है. स्केच कैसे करते हैं? Remember, f of x और f inverse of x क्या होते हैं? एक दूसरे का इनवर्स होते हैं इस लाइन के अंदर, एक दूसरे के रिफ्लेक्शन होते हैं इस लाइन के अंदर, y equals x लाइन के अंदर. तो इनके रिफ्लेक्शन रफली किस तरह से बन रहे होंगे यहाँ पे? How do we think about this? ओरिजिन वाला पॉइंट उधर ही रहेगा, राइट? ये पॉइंट इधर ही रहेगा. अब आप रफली यहां से देखें, फॉर इंस्टेंस अगर इन पॉइंट्स को हम कुछ मार्क कर लेते हैं, लेट्स से दिस पॉइंट, अगर ये है रफली 2 and 1, 2 and minus 1, okay? If this was 2 and minus 1, इनवर्स में क्या हो जाएगा? ये -1 2 इंटरचेंज हो जाएंगे कोऑर्डिनेट्स. 2 -1 है, इनवर्स में जाके ये -1 2 हो जाएगा. -1 and 2 ये थोड़ा सा ऊपर चला जाएगा इधर. तो ये जो नीचे वाला पॉइंट था इधर, that goes to the other side like this, right? अच्छा, अब अगर ये थोड़ा सा दूर एक पॉइंट ले लें, let's think about this. ये पॉइंट क्या है? This will be roughly, अगर वो 2 था तो इसको हम कह लेते हैं 4, और नीचे जो है -1 से नीचे थोड़ा ज्यादा जा रहा है, let's say 4 -6, right? roughly अगर ये पॉइंट है इस तरह से, इसका ऑपोजिट क्या आएगा? किधर जाएगा ये? -6 4, लेफ्ट साइड पे ज्यादा और ऊपर उतना ज्यादा नहीं, मे बी समवेयर हियर. और उससे आपको आइडिया हो गया कि शेप कैसी बनेगी ग्राफ की. इट्स गोइंग टू लुक लाइक दिस. ये आपका ग्राफ होगा इस साइड के ऊपर, लाइक दिस. मेक सेंस? एंड यू कैन डू द सेम थिंग ऑन द अदर साइड, बट आपको अब इससे अंदाजा हो जाएगा व्हाट द अदर साइड इज गोइंग टू लुक लाइक. नाउ इसी पैटर्न को फॉलो करते हुए इट्स गोइंग टू बी लाइक दिस. ये आपका इनवर्स का ग्राफ है. मेक सेंस? आपने स्केच करना है. द एग्जैक्ट पॉइंट्स आर नॉट इंपॉर्टेंट. ये हमने सिर्फ समझने के लिए किया कि जब इसको इंटरचेंज करेंगे तो वो क्या बनेगा. बट दिस इज व्हाट द शेप इज गोइंग टू बी लाइक. दिस इज द ग्राफ ऑफ y equals f inverse of x. ये क्लियर है? इसमें क्या मसला? Another way to think about this could be आप y equals x लाइन ड्रॉ कर लें और अपना रूलर रख के आप रिफ्लेक्शन करने की कोशिश कर लें कि अगर ये वाला पॉइंट है फॉर इंस्टेंस ओरिजिनल ग्राफ पे ये, तो ये उधर जाके किधर चला जाएगा, रिफ्लेक्ट होके इट्स गोइंग टू बी समवेयर अराउंड हियर। तो अब हम मेजर करके कर लें रूलर पे, 2-3 पॉइंट्स मार्क करेंगे, आपको अंदाजा हो जाएगा शेप कैसे लगेगी। मेक सेंस? y इक्वल्स x में रिफ्लेक्शन नहीं चाहिए। अच्छा, ये ग्राफ स्केच कर लिया अब आपने। अब सेकंड पार्ट में वो कहते हैं इट्स नाउ गिवन दैट f of x equals this। अब उसने वो फंक्शन दे दिया आपको where x is between -2 and 2, you need to find an expression for f inverse of x। इसका inverse निकाल लें इस फंक्शन पे। Let's find the inverse of this function। इससे क्या करेंगे, वही स्टैंडर्ड प्रोसेस जो हम करते हैं, f of x equals -x over square root of 4 minus x squared। That's what the function is। How do we start? We say let y equals f of x। f of x की जगह पे y input कर दें। That gives you y equal to -x over square root of 4 minus x squared। Right? अब आपने क्या करना है, x को सब्जेक्ट बनाना है। x को सब्जेक्ट बनाने के लिए अब क्या करते हैं, पहले तो स्क्वायर रूट खत्म कर सकते हैं अभी इसी पॉइंट के ऊपर। हाउ डू यू रिमूव द स्क्वायर रूट? दोनों साइड्स को स्क्वायर कर दें। इफ यू स्क्वायर बोथ साइड्स, ऑन द लेफ्ट साइड वी गेट y स्क्वायर्ड, ऑन द राइट साइड वी हैव -x का होल स्क्वायर्ड। वो क्या हो जाएगा, नेगेटिव साइन खत्म हो जाएगा because of the square। We're just left with x squared। In the denominator we would have 4 minus x squared because square root खत्म हो जाएगा स्क्वायर करने से। This is what we get। इसमें क्या मसला, ये क्लियर है? अच्छा, अब देखिए अब क्या होगा, अब नीचे डिनोमिनेटर को उधर मल्टीप्लाई कर दें लेफ्ट साइड पे। That gives you 4y squared minus x squared y squared equals x squared। Take x terms to one side, x squared minus x squared y squared, on the other side you have y squared। You can take x common now, x squared common, that leaves you with 1 minus y squared in the middle। We have 4y squared here। x squared equals 1 minus y squared divided by 4y squared। यहाँ तक ठीक है? No? Okay, the other way around। I'm sorry, it's 4y squared over 1 minus y squared। ठीक है, this is what x square is equal to। इसमें क्या मसला नहीं? अब हमें क्या करना है, इसका स्क्वायर रूट लेना है, राइट? When we take square root, what do we get? We get x equals plus minus square root of 4y squared divided by 1 minus y squared। This is what we get। इसमें क्या मसला? ठीक है। अच्छा, अब उसने यहाँ पे इंटरवल क्या दिया हुआ था x का? x का इंटरवल is from -2 to 2, -2 to 2। It's a 1-to-1 function throughout। तो ये ऐसा, इसमें नेगेटिव साइन था, f of x was negative और x was negative। अच्छा, अब आपने डिसाइड करना है इसका साइन प्लस माइनस। दिस इज स्लाइटली कंफ्यूजिंग नाउ। x equals plus minus square root of 4y squared over 1 minus y squared। अब आप प्लस माइनस में से आपको एक चीज डिसाइड करनी है, इसमें से आपको प्लस लगाना है माइनस लगाना है। रिमेंबर क्वाड्रेटिक फंक्शंस में कैसे करते थे, हम देखते थे x की डोमेन क्या है, उसकी बेसिस पर हम डिसाइड कर लेते थे कि अच्छा प्लस लगाने से वो आएगा या माइनस लगाने से वो आएगा। लुक एट दिस फंक्शन, जो उसने फंक्शन दिया हुआ है, इस फंक्शन में उसने ओरिजिनल फंक्शन में माइनस यूज किया हुआ था, राइट? माइनस वाज व्हाट यू हैड आउटसाइड। इसका मतलब क्या है, जब हम x की वैल्यू को यहाँ पे पॉजिटिव इनपुट करते थे, x की वैल्यू के पॉजिटिव डालेंगे ओरिजिनल फंक्शन के अंदर, उससे y की वैल्यू क्या आएगी? y की वैल्यू पॉजिटिव आएगी नेगेटिव आएगी? y की वैल्यू नेगेटिव आएगी, बिकॉज नीचे वाला पार्ट तो पॉजिटिव ही है, वो स्क्वायर रूट के अंदर है, अंदर वाला पार्ट तो वो तो पॉजिटिव रिजल्ट आएगा। अगर x की वैल्यू हम पॉजिटिव डालते हैं बिकॉज ऑफ दिस नेगेटिव साइन, द y वैल्यू वुड बी नेगेटिव। ये तो उसने ऑलरेडी लगाया हुआ ना पहले से। अंडर रूट में प्लस माइनस तब करते हैं जब आप खुद लगाते हैं। ये हमने पहले भी डिस्कस किया क्लास में कि नहीं किया? जब खुद से आप स्क्वायर रूट लेते हो देन यू पुट प्लस माइनस। इफ द स्क्वायर रूट इज ऑलरेडी देयर, उसने जो साइन यूज किया हुआ है वहां पे वही यूज करना है। वहां पे उसने नेगेटिव लगाया हुआ है बाहर, तो ये नेगेटिव ही रहेगा। ओके, तो अगर x की वैल्यू आप यहाँ पे पॉजिटिव इनपुट करते हो, y की वैल्यू क्या आती है? नेगेटिव। आप ग्राफ पे भी देखें, जब x पॉजिटिव है तो y क्या आ रहा है? y नेगेटिव आ रहा है। और जब x नेगेटिव है तो y क्या आ रहा है? y पॉजिटिव आ रहा है। अब देखिए, उसने आपसे इनवर्स का ग्राफ भी स्केच कराया फर्स्ट पार्ट में। इनवर्स के ग्राफ में भी देखें क्या हो रहा है। इनवर्स के ग्राफ में भी जब आप x की वैल्यू पॉजिटिव इनपुट करते हो, व्हाट्स द वैल्यू ऑफ y दैट यू गेट? नेगेटिव। x की वैल्यू जब नेगेटिव इनपुट करते हो, द वैल्यू ऑफ y इज पॉजिटिव। यहां पे भी उल्टा हो रहा है। इनवर्स में भी अब आपको वही करना है कि अगर आप पॉजिटिव वैल्यू ऑफ x इनपुट करो तो नेगेटिव है, नेगेटिव इनपुट करो तो पॉजिटिव है। ओके, अच्छा, अब पहले तो हम इसको थोड़ा सिंप्लीफाई कर लेते हैं, बिकॉज 4y², दिस कैन कम आउटसाइड द स्क्वायर रूट नाउ। 4y² का स्क्वायर रूट क्या होगा? 2y. So we can write it as x equals plus minus 2y over square root of 1 minus y². इसको सिंप्लीफाई नहीं कर सकते डिनोमिनेटर को। अब देखें, जब हम इनवर्स में डाल दें, इसको कन्वर्ट कर दें अगर इनवर्स वाली फॉर्म के अंदर, यू गेट f इनवर्स ऑफ x इक्वल्स प्लस माइनस 2x डिवाइडेड बाय स्क्वायर रूट ऑफ 1 माइनस x²। नाउ वी नीड टू डिसाइड वेदर टू पुट प्लस देयर और माइनस देयर। प्लस और माइनस में से क्या डालेंगे अब यहाँ पे? x की वैल्यू हम चाहते हैं कि जब पॉजिटिव इनपुट करें तो रिजल्ट नेगेटिव आए, जब नेगेटिव इनपुट करें तो रिजल्ट पॉजिटिव आए। सो विच वन ऑफ दीज टू साइंस शुड वी चूज हियर? पॉजिटिव और नेगेटिव? नेगेटिव। x की वैल्यू पॉजिटिव इनपुट करने से वी वांट y टू बी नेगेटिव, और x की वैल्यू नेगेटिव इनपुट करने से वी वांट y टू बी पॉजिटिव। x की वैल्यू पॉजिटिव इनपुट करेंगे तो नेगेटिव कैसे होगी अगर बाहर माइनस लगा होगा? अगर नेगेटिव इनपुट करेंगे तो वो पॉजिटिव कैसे होगी अगर बाहर माइनस लगा होगा? तो बाहर आपको कौन सा साइन चूज करना है? पर यहाँ पे नेगेटिव साइन। तो फिर आप फाइनल रिजल्ट क्या रखोगे? you'll say f inverse of x is equal to minus 2x divided by square root of 1 minus x². That is what the inverse turns out to be. आप इस पे नेगेटिव चूज करोगे। Is that okay? प्लस माइनस जब भी आएगा आपने एक डिसाइड करना होता है उसके अंदर से। यू कांट हैव बोथ लाइक दिस, बिकॉज प्लस माइनस अगर दोनों आ जाएंगे ना, ये फंक्शन इस तरह का बन जाएगा। ये ऊपर वाला पार्ट ऐसे भी होगा, कुछ नीचे ऐसे भी होगा। दैट्स नॉट इवन अ फंक्शन, राइट? फिर ये पूरा ये आ गया और ये आ गया, ये तो फंक्शन नहीं है। तो प्लस माइनस में से एक पार्ट आपने चूज करना है, देन इट विल रिमेन 1 to 1 लाइक दिस। मेक सेंस? अच्छा, उसके बाद वो क्या कह रहे हैं? फंक्शन g is defined by g of x equals to x for x between minus a and plus a, where a is a constant. State the maximum possible value of a for which fg can be formed. Remember this? Composite functions की क्या condition होती थी? When can a composite function be formed? क्या चीज? स्क्वायर रूट में 0 से कम नहीं हो सकता? कॉम्पोजिट फंक्शन फॉर्म करने की क्या कंडीशन होती है? fg of x, this is the function that we want to form, right? G is the inner function, f is the outer function. Remember the condition that we had for that? Inner function की जो range होती है, that should be part of the domain of the outer function, right? Range of the inner function should be part of the domain of the outer function. We did this here in functions. This was actually the only tricky part of functions. Apart from transformations, composite functions में हमने ये domain और range की बात की थी. A composite function fg of x can only be formed if the range of the inner function is part of the domain of the outer function. Otherwise तो वो break हो जाएगा function. जो अंदर वाला function output दे रहा है वो बाहर वाले function में input होना चाहिए. अगर वो नहीं हो सकता then we have a problem. Is that okay? So generally we remembered it like this कि जो range of inner function है that would correspond to domain of the outer function. Right? ये हमने composite functions में किया था. Now let's think about this. What's the inner function? Inner function is G. Outer function is F. Inner function की range क्या है? This is the inner function G. Let me write that here. Or C. उसने एक function दिया है G of X, which is 2x, where X is between minus A and plus A. Right? अगर ये डोमेन है, इट्स अ स्ट्रेट लाइन, इसकी रेंज क्या होगी? इस फंक्शन की रेंज क्या होगी? कल टेस्ट है आप लोगों का. स्ट्रेट लाइन फंक्शन है, इसकी डोमेन गिवन है, इसकी रेंज क्या होगी? जैसा ना अभी देखते हैं, ये तो कर लें, आप बहुत आगे पहुंच गए. ये पहले ये देखें, ये डोमेन है माइनस ए से ए के दरम्यान में, इसकी रेंज कैसे निकालेंगे? ये 2x फंक्शन है ना, इट्स अ स्ट्रेट लाइन लाइक दिस. तो एक पॉइंट पे वैल्यू ऑफ ए इज वैल्यू ऑफ एक्स कोऑर्डिनेट इज माइनस ए, दूसरे पे इट्स प्लस ए. तो इनके कॉरेस्पॉन्डिंग वाई कोऑर्डिनेट्स क्या आते हैं? 2a एंड माइनस 2a. तो रेंज क्या हो जाएगी फंक्शन की? Range of the function, range of G, which is the inner function, this is from minus 2a to plus 2a. ये इस फंक्शन की रेंज है. ठीक है, अब ये कॉरेस्पॉन्ड करनी चाहिए टू द डोमेन ऑफ द आउटर फंक्शन. नाउ व्हाट्स द आउटर फंक्शन? दिस वाज द इनर फंक्शन. F of x is the outer function. What was f of x? F of x was minus x over square root of 4 minus x squared. And this was defined for x between minus 2 and plus 2. Okay? अब ये दोनों एक दूसरे को correspond करने चाहिए. This is the outer function, f of x. Outer function की domain और inner function की range. This thing and this thing, they should correspond to each other. Is that okay? अब देखें उसने क्या कहा है? Find the maximum possible value of A for which FG can be formed. अब यहाँ पे अगर हम A की वैल्यू, अगर ये दोनों correspond करते हैं 2A और 2, तो A की वैल्यू क्या आती है? 1. The maximum value of A that you can have here is 1. 1 से अगर ज्यादा होगी तो क्या होगा? ऊपर वाले फंक्शन की रेंज क्या हो जाएगी? अगर लेट्स से हम A की वैल्यू 1.5 डाल देते हैं, अगर A की वैल्यू 1.5 हो जाती है तो रेंज क्या हो जाएगी ऊपर वाले फंक्शन की? -3 से लेकर +3 तक. -2 into 1.5 to 2 into 1.5, that's -3 to 3. अब ये आप इसके अंदर इनपुट नहीं कर सकते, right? Because कुछ पार्ट जो है इसकी डोमेन से बाहर जा रहे हैं. So the maximum value of A that we can have is 1. 1 से ज्यादा नहीं, 1 से कम होगी that will be acceptable, because 1 से कम होने का मतलब क्या है कि अगर हो सकता है कि यहाँ पे आ जाए 1.5, -1.5 to +1.5, अभी सारी की सारी वैल्यूज वहां पे जाके इनपुट हो सकती हैं. So the maximum possible value is 1. Is that okay? ये clear है? Does this answer your question as well? जो आप पूछ रहे थे, आप क्या कह रहे थे? मैक्सिमली 1 होगी, इससे ऊपर नहीं जा सकते. ठीक है, so this is the greatest possible value of it. Now assuming that fg can be formed, find and simplify an expression for fg of x. Now this is straightforward. बस आपने ये तो वैल्यू वो फंक्शन इवैल्यूएट करना है. दोनों फंक्शंस हैं आपके पास, fg आपने फाइंड करना है. एफ जी कैसे आएगा अब इसमें से? ये दोनों फंक्शंस हैं एफ और जी। एफ के अंदर जी इनपुट कर दें, एफ जी ऑफ एक्स, वी could write it as f of g of x, and that becomes minus, or let me write it like this first, g of x is 2x, so f of 2x, ये बस आपने यहाँ पर इनपुट करना है, minus 2x divided by square root of 4 minus 2x का होल स्क्वायर। जहां भी x था उस फंक्शन के अंदर उसकी जगह पे 2x डाल दें। Now you could simplify this a bit. That gives you minus 2x divided by square root of 4 minus 4x squared. उसने कहा find and simplify this expression. Can you simplify this more? और simplify कर सकते हैं? क्या करें इसको? You could take 4 common. 4 common ले लें denominator में से, तो ये क्या बनेगा? 4 into 1 minus x squared, इसका square root. अब square root of 4 बाहर लेके जा सकते हैं. It becomes minus 2x divided by 2 into square root of 1 minus x squared. 2 and 2 get cancelled, and we are left with minus x over square root of 1 minus x squared. This is fg of x. तो ये simplification के भी marks होंगे, उसने specify किया कि आपको simplify करना जरूरी है।